Greetings, good people. We meet once again. We continue with our genetics. We are now focusing on a section called heritability. We will combine heritability with EBV, which is estimated breeding value. So that's what we will check when we look at this one. When we focus on this one, the first thing we must be able to define heritability. We must also be able to define estimated breeding value. When we define the heritability, we will categorize heritability into two, or will range heritability from 0 to 100. So you will see what kind of characteristics that begin from 0 to 49, which is less than 50, and those that are above 50. So that's what we will check. We will then look at EBV, and when we look at EBV, we will do a lot of calculations. So it's very important to bring your calculator nearby. We will look at some calculations there, and I will request you to make sure that you pay more attention when we deal with the calculations. Let us start with this one. What do we mean by heritability, good people? When we focus on heritability, we say this is the degree to which characteristics are determined by genetic factors, or we can say is a proportion to which characteristics are determined by genetic factors. There are some characteristics that are mostly determined or mostly influenced by genetic factors, and there are some that are mostly influenced by environmental factors. So when we look at this one, heritability, we want to check the chances of a characteristic being determined by genetic factors. Then we will check at what happens to the characteristics that is mostly influenced by genetic factors. So make sure that you take note of the definition. In 1.3, they can use either degree, or they can use proportion, but we say is the degree to which characteristics are determined by genetic factors. So we focus on those characteristics that are mostly influenced by genetic factors. When we look at this one, we talk about heritability. Heritability is range from 0 to 100 when we range heritability. So I want me and you now to look at what happens to the characteristic that is less than 50% and what happens to the characteristic that is more than 50%. When we talk about heritability, we say a characteristic with a heritability that is less than 50%. This characteristic, we say it is influenced by environmental factors. And a characteristic that is mostly influenced by environmental factors, we say this characteristic cannot be transferred to the offspring. And such a characteristic that cannot be transferred to the offspring, it simply means that a farmer cannot use that characteristic in a breeding program, or cannot choose an animal with a characteristic that is less than 60, that is less than 50%. Why? Reason number one, the characteristic is having a heritability that is less than 50%. Two, that characteristic is mostly influenced by environmental factors. Three, the characteristic cannot be passed or cannot be transmitted or transferred to the offspring. So if you want to master a characteristic, a heritability, we say once the characteristic is having a heritability that is less than 50%, it is influenced by environmental factors. It cannot be transferred from parents to offspring. Three, then we say it is not suitable for breeding programs. So we cannot advise a farmer to use a characteristic with a heritability that is less than 50%. What about the characteristic that is more than 50%? A characteristic with a heritability that is more than 50%. We say that characteristic is mostly influenced or mostly controlled by genetic factors. And a characteristic that is controlled by genetic factors is a characteristic that can be transferred to what? To the offspring. So if we say this characteristic can be transferred to the offspring, it simply means that it is suitable or it is good for a breeding program. So this is what you must have as your background knowledge before we move on to talk about heritability together with EBV when we look at the calculations. We are saying, good people, if the characteristic is less than 50%, is having a heritability that is less than 50%, that characteristic is influenced by environmental factors. But if the characteristic is more than 50%, it is influenced by genetic factors. Then you have to know that a characteristic that is influenced by environmental factors cannot be passed or cannot be transferred to the offspring. But a characteristic that is influenced by genetic factors, it can be transferred to the offspring. Then we say the characteristic that cannot be transferred to the offspring is not suitable for a breeding program. There is no way you can take an animal with a characteristic that cannot be transferred and say you want to breed that animal. Why you are breeding the animal? Because the characteristic that you are looking for, that you are focusing for, cannot or will not be passed to what? To the offspring. So you better go for the characteristic that will be transferred to the offspring. And that characteristic that will be transferred to the offspring, one, it's a characteristic that is having a heritability that is more than 50% and is also influenced by genetic factors. That's what you must understand when we look at this one. In some cases, good people, we will look at some of the questions. You will find that they give you characteristics. Let us say this is characteristic A. Characteristic A, let's say they say it's 38, is having a heritability that is 38%. Then you have characteristic B, is having a heritability that is 86%. Then a question comes and say, make sure that you take note of this part. Then a question comes and say, which characteristic would you advise a farmer to select in a breeding program? Which characteristic will you advise a farmer to select in a breeding program? You have to note that the characteristic that you must advise a farmer to select in a breeding program is a characteristic that is having a heritability that is more than 50%. So you look at AB. The one that is having a heritability that is more than 50% is characteristic B. You say characteristic B, maybe it will be given a name or say slaughter weight, post-winning weight, or fleece weight. Then you say, then the next question says, provide a reason. You have 2 marks there. Maybe they will not tell you that 2 reasons. They will just say provide a reason, but mostly it's 2 marks. Reason number 1, you say, this characteristic is having a heritability that is more than 50%. You get your mark. 2, you say, it is mostly influenced or controlled by genetic factors. You can add and say it can be transferred. So once you understand it in this manner, we will be able to move on and look at the other questions. This is what I want you to note here when it comes into heritability. We said it is a degree or proportion to which characteristics are determined by genetic factors. Allow me to talk about estimated breeding value, good people. Let's first look at the definition, then we will look at the importance of EBV before we look at the calculation. It's very important to know that the EBV stands for estimated breeding value. There is a question that came whereby they were asking, what does the EBV stands for? It's estimated breeding value. What do we mean by EBV? We say is an estimate of how much better or less than average the offspring of an individual will be for a particular characteristic. So we want to check whether will the offspring have greater than the average or less than the average for that particular characteristic. When we breed that animal, we want to check whether will the offspring have greater than the average of the head or less than the average of the head. So when we define it, we say it's an estimate of how much better or less than average the offspring of an individual will be for a particular characteristic. You will see when we provide the implication whereby we're saying the animal will be having a so and so kg greater than average. That's when we will talk about the implication after doing the calculation. Let us look at the importance before we go to the calculation. There are two reasons why EBV is important. One, it's indicating the heritability of a particular characteristic. So it is the one that will tell us whether that characteristic will be transferred or will be heritable to the offspring. So we say it indicates the heritability of a particular characteristic. Two, it is the one that will predict the success of a breeding program. If we say the breeding program is successful, we will see by the fact that the animal or the offspring is having a greater post-winning weight, a greater slaughter weight, a greater fleece weight. That's what we will check. So there are two importance of EBV, of using EBV. We want to indicate the heritability of a particular characteristic. Two, we want to predict the success of a breeding program. Let us focus on the calculation. Bring your calculator closer to you. Let us deal with some calculations now. How to calculate EBV? There are two formulas that we have here. I want you to know, when do we use the first formula that I will share with you, and when do we use the second formula? So let's try to check. Formula number one, it says EBV is equal to winning weight of the animal minus average winning weight of the head or of all the animals. We say winning weight of an animal minus average winning weight. That's the first formula. I will highlight to you when do we use the first formula and when do we use the second formula. Okay, let us check the second formula. When we look at the second formula, it says, formula number two, it says EBV is equal to winning weight of animal minus average winning weight of the animals. Then you open the brackets, heritability divided by 100. We will be given a heritability. We will be given characteristics with their heritability. So we will substitute with that one. It will be in a form of percentages. So what we are saying here, we are saying it will be winning weight of animal minus average winning weight. Then we say multiply Hence, we say we open the brackets, multiply by the heritability, divide by what? Divide by 100. That's what we will check here. Now the question, my good people, how do you know which formula to use? How do we know that now we are supposed to use formula number 1? Now we are supposed to use formula number 2. Let us look at it. If a question, this is the key part, if the question says calculate the EBV, then the question says, then there's period, a full stop. You use formula number 1. Once it says calculate the EBV, they can say EBV of the animal, EBV of parent 1, EBV of parent 2, or EBV of the male, EBV of the female. You just use the first formula. But then, when now they say calculate, if the question says calculate the EBV, take note of this part. Calculate the EBV of heritability. Maybe they will say of genetic gain. You use the second formula. The question will say calculate the heritability of genetic gain or of heritability, or else they will give you the name of that heritability or the name of the characteristic with that heritability, whereby they say calculate the EBV of, let me highlight it, calculate the EBV of birth weight, calculate the EBV of post-weaning gain, calculate the EBV of meat tenderness, calculate the EBV of slaughter weight, calculate the EBV of fleece weight. That's when you will use the second formula. But if it just says calculate EBV, then there's a full stop. You use the first one. If it says calculate EBV of genetic gain or heritability or any of these characteristics that I have highlighted here, you have to use the second formula. For us to get it nicely, let us have some few examples and make sure that you follow each and every argument here. Let us have example number 1. They give you will get a statement. The statement says, farm records show winning weight is 250 kg and average winning weight is 210 kg. That's what they give you. Winning weight is 250. The average winning weight is what? Is 210 kg. Then they say, then they give us something for us to calculate. Let's see what can we calculate here. The question says, calculate the EBV of the animal. Do you see that the question ends there? They never say, they even said calculate the EBV of slaughter weight, calculate the EBV of meat tenderness, calculate the EBV what? They just say calculate the EBV of what? Of the animal. So once they say calculate the EBV of the animal, then what do? We choose the formula. It means we will use formula number 1. The first thing when you do a calculation, if you recall, you write the formula. What does it say? Estimated breeding value is equal to winning weight of animal minus average winning weight. You will get a mark for writing the correct formula. Once you write the formula, then you substitute. What is our winning weight of the animal? Is 250 kg. What is our average winning weight? It's what you say minus 210 kg. By substituting, you get a mark again. Maybe here we'll have we now have 2 marks. Then you punch your calculator. After punching your calculator, this is the substitution that we had. After punching your calculator, you punch your calculator, what do you get? You get 40. You get 40 kgs. The units of this one are kgs. You get 40 kgs. By getting your answer, you get a mark. Maybe they will also award a mark for the units, but let's just say there's no mark for units in this example. So the first thing that we did here, we're able to master we were able to get which formula were they requesting, and we chose formula number 1, which says EBV is equal to winning weight of animal minus average winning weight. We substituted, we punched our calculator, we got our answer. This is what you must understand. Mostly, when they give you such questions, they will also expect you to talk about implication. What does the figure that you got implies? Let's talk about the implication. This means that the animal is having a positive breeding value. We'll talk about the breeding value later. But then don't worry about this one. This is what it says, good people. It can be expected to produce an offspring with a winning weight that is 40 kg greater than the animal's average weight. Remember, we said when we talk about EBV, we said is an estimate of how much better or less than average an offspring will be for a particular characteristic. So we say here we'll be having a positive breeding value. 2, the answer that you got to say the animal will be having 40 kg greater than the average winning weight. The animal will be having 40 kg greater than the average winning weight of the animals. Then you can also say it means it will be having 250. Where do we get the 250? We said the average winning weight of the animals plus the answer that we got plus the EBV that we got, which is 40. Then we came up with 250. But when you talk about it, you will say the animal will be having, or the offspring will have so and so kg greater than, if it's positive, it means it will be greater than it. So and so kg greater than the average winning weight of the animal. In this case, it's 40 kg. Let's try to look at another example. Example number 2. This is what we have. They say here, good people, average slaughter weight. Make sure that you take note of these figures, because on the other slide we don't have it. The average slaughter weight of the flock is 47.5 kg. That's the average. The parent weighs 52.5 kg. Then they say the table below shows the heritability characteristics of sheep. You have the winning weight, which is 52.5. You have the average winning weight, which is 47.5. Then you have the table here. It's a characteristic with a heritability. The birth weight is 49. The post-winning weight is gain, it's 50. The mid-tenderness is 60. The slaughter weight is 85. And then the fleece weight is 50. If you can recall, remember, which one would you not advise a farmer to use in a breeding program? Remember, the one that you will not advise a farmer to use is the one that is less than or more than 50. Yes, the one that is less than. So it means we cannot advise a farmer to use a birth weight. Why? Because it has a heritability that is less than 50%. It means the characteristics are controlled by environmental factors, so it cannot be transferred. Okay, fine, I'm not there. Let's try to check what does the question want. Question number 1. Use the heritability value to calculate the slaughter weight. Genetic gain in brackets. Show all calculations including the formula. And they even tell you including the formula. Remember, I said there are two formulas. Formula number 1, winning weight minus average winning weight. Formula number 2, winning weight minus average winning weight multiplied by heritability divided by 100. I said, when the question says calculate the EBV, you use the first formula. But if the question says calculate the EBV of so and so, in this case calculate the slaughter weight, genetic gain, show all calculation, it means we will use the second formula. So what do? The first thing that we do, we start by writing the formula. Always you write your formula. What does the formula say? You say EBV is equal to winning weight of the animal minus average winning weight. You open the brackets, you say heritability divide by what? Divide by 100. Then you have to substitute. This is our formula, ne? Then you have to substitute. You check on the other slide, I said take note of the figures there. You will say our winning weight. We said our winning weight is what? It's 52.5 kg. Our average winning weight is 47.5 kg. You open the brackets. Remember, when you open the brackets, it means we will multiply there. Heritability, we are calculating for what, good people? We are calculating for slaughter weight. What is the heritability for slaughter weight? You go to the table. You check it. Here it is in the table. You take it from the table. So we get it from the table. So we come here and say, okay, fine. It's what? It's 85. You say 85% divide by what? Divide by 100. So what I want you to do, I want you to start by dealing with what is outside the brackets, and then you will deal with what is inside the brackets later. Okay, fine. The first thing you can do, you will say 52.5 minus 47.5. You open the brackets, 85% divide by 100. I want you to start by punching your calculator only what is outside the brackets for you to master it, because we sometimes punch a calculator in the wrong way. You say 52.5 minus 47.5. You will get 5 kgs. Then you say multiply. You come here and say 85 divide by 100. You will get 0.85. Then you come and say 5 multiply by the 0.85. You will come up with 4.25, which can be round off to 4.3 kg. Okay, fine. We don't forget the units. Okay, fine. Let's try to check how we did it here. We said 52.5 minus 47.5. We got 5 kg. Then we said the 5 kg multiplied by the 0.85. Then we got ubani 4.3. The 4.3, which we can say is 4.25 kg. That's the simplest way, good people. The way we did it down there, I hope you will be able to do it the way I was writing it. You start by dealing with what is here. You write an answer. You deal with what with inside the brackets. You write an answer, and then you multiply. You will end up getting the 4.25 kg. That's the simplest thing. That's the simplest thing. Okay, fine. Let's see what we can get. What does the implication say? Remember I said the answer that you will get, you will say the offspring will be so and so greater than the average winning weight of the animals. Then you say the offspring will have a slaughter weight of 51.8. Where do we get the 51.8? We said the average plus the answer that we got, which is 4.3. So the offspring will be 51.8 kg. Or else we say the offspring will be 4.3 kg heavier or greater than the flock average. That's the simplest way when you want to understand the implication. You just say the offspring will be, then you write the answer that you got, greater than the average winning weight of the animals. That was example number 2. They can also say calculate for birth weight. When they say calculate for birth weight, you will say 52.5 minus 47.5. What is the heritability for birth weight? It is 49. Then you say multiply with open brackets 49 divided by 100. You punch your calculator, you will get an answer. You can also practice it on the side. Okay, fine. Let us look at example number 3, which is the last example. You can see that these examples are different, good people. You can get more practice. You can get more practice on your own if you get some questions. Okay, fine. A goat farmer wants to increase the winning weight of his herd. The average winning weight, you take dot of the average. The average winning weight of the herd is what? Is 17.5 kg. He selects the male and the female goat with the highest winning weight. Let us check the winning weight of the male. The winning weight of the male is 19.6 kg. The winning weight of the female, what does it say? It's 18.7 kg. So this is what we have. We have the average winning weight of all the animals. Then for the male, it's what? It's 19.6. For the female, it's 18.7. No, not that one. Not that one down there. Let us check what do they say. The heritability that we have, they are saying heritability that we have is how many percent? 60%. Okay, fine. Calculate the EBV of each parent. That's the question that we get. Calculate the EBV of each parent. Take note of this one. If they say calculate the EBV of each parent, good people, it means we will calculate the EBV of the male and calculate the EBV of the female separately. And remember that we have two formulas. It's very important to know again which one are we using here. They said calculate the EBV of the, then they gave us the animal, of the male. of the female. So do we go for formula number 1 or number 2? We go for number 1 because they said for us to calculate for formula number 1, for us to use formula number 1, it must only be like this. But if they want us to calculate if they want us to use number 2, they were gonna say for heritability of so and so. That's when we are gonna use number 2. Let us check. The first thing is your formula. This is the formula that they used. Animal EBV of male. Animal winning weight is minus average head weight. Then you substitute. What is the winning weight of the male is 19.6 minus the average. The average is 17.5. That's what we have. So we got our answer, which is 2.1 kg. If they want us to provide an implication, what will you say? You will say the offspring will be 2.1 kg greater than the average winning weight. Okay, but one not there. Let's look at the one of the female. Again, we use the same formula. Animal winning weight minus average head weight. You substitute 19.6, you substitute 18.7 minus 17.5. What do you get? You get 1.2 kg. The key thing is to know which formula you are supposed to use. Okay, fine. Let's make it difficult a little bit. I hope you get this slide. Ne? We're calculating for one parent, ne? For each parent. So we calculated for the male and we calculated for the female. Let's check what are they saying here. They are saying calculate the combined EBVs. Calculate the combined EBVs. So we want to know now what will be the EBV of the two parents. This is how I want you to understand it. I want you to understand it in a way that each of these parents will contribute. Half of its EBV. So it means the male will contribute half of 2.1, the female will contribute half of 1.2, and then we will combine these two and get the EBV of the parents combined. I don't know if I'm confusing you. Then you will say combined EBV of parents. You will say male plus EBV of male plus EBV of female. You get your answer. Then you divide all of them by 2. So you will say the EBV of the male, which is 2.1, the EBV of the female, which is 1.2. You get your answer, which will be 3.3. And then you say divide by 2. Then you get what? Your 1.6. That is the EBV of the parents combined, good people. So in this case, just understand that we are told that each parent contributes 50%, each parent contributes 50%. So we want to get half of the male, half of the female, and then we want to know what will be the EBV of of the parents combined. Calculate the expected winning weight of the offspring. Calculate the expected winning weight of the offspring. What you are supposed to do here, good people, you must say the expected genetic gain. You will say the combined EBV of the two parents multiply by the heritability, divide by 100. I beg your pardon, good people. Sorry, here was supposed to have divide by 100. Sorry with that. Divide by 100. So you will say the combined EBV of the parents which we got, which is 1.6, multiply by heritability. Our heritability, we said it's 60%, divide by 100. Let us check. So it means we will say 1.6 multiplied by 0.60 after dividing by 100. 0.60, and then we will get our answer, which is 0.96. That will be the expected genetic gain of the offspring. So if this is the expected genetic gain of the offspring, you see that these examples are different. Then if they can say, what will be the implication? Then you will say the offspring will be, or the offspring is expected to be 0.96 kg greater than the average winning weight of what? Of the parents. So that's how we can understand it. That's how it's supposed to be. But what I want you to note here, just note that I used 3 different examples. Because of time, I was going to use more and more examples. I used 3. 1, know which formula to use. Calculate the EBV. You go for the first formula. EBV is equal to winning weight minus average winning weight. Calculate the genetic gain. Then use the second formula that will end up saying multiply by heritability, divide by 100, the second formula. And then note that sometimes they can say calculate for each parent, for the male, for the female. So when they say calculate for the male, you calculate for the male separately, for the female separately. If they say combined, calculate the EBV of the parents combined, you add the EBVs of the 2 parents, and then you divide them by what? By 2. Then you will get what? You will get the correct answer. So that is the simplest way of understanding this one. But for you to get it nicely, it's very important that you get more questions to practice. But I will also try to create another slide where we will only focus on the calculations, only. Especially the second example is the one that is very important. So let's make sure that we understand it in that simpler way, good people. Thank you.